everybody see my presentation title there?
Wow,
okay.
That's pretty.
Thanks. So my name's Scott Curry, NS7C. You may, if you've been around Winlink for a while, you've probably seen my call sign up on the forums. I'm one of the forum moderators and help folks out when I can. When I'm not doing that kind of stuff, I work for the city of Auburn, Washington. I work in the emergency management office. I'm assistant to the emergency manager. And in that role, I manage the volunteers, which includes our auxiliary communications team. And I also maintain all the radio systems there at the EOC, not only the ham stuff, but all the public safety and radio systems as well. Even our AM radio station, we have a Travelers Information Station on 1700 AM. We maintain that as well. So I was asked to see if I could put together a presentation for doing do-it-yourself Soundcard interfaces for Winlink use, and I've done that before. So I said, okay, yeah, I can talk about that. This will not be a terribly in-depth technical discussion. I don't really want to go there. I want to give you some ideas that you might want to experiment with and places where you can go to get additional resources if you want to roll your own Soundcard interface. And I'm going to talk about other options because it may not be the best option to roll your own, but we'll talk about that here in a little bit. Let's see. So, you know, I've used the slide deck for a couple different things, or the base of the slide deck for a few different presentations I do. And I usually have a couple of slides right at the beginning here where we talk about, you know, what's Winlink all about? Why would you want to do that? I assume that you're all, if you've made it to 10 of these presentations, you probably have a pretty good idea why you want to utilize Winlink for emergency communications. So I won't spend much time on these. Hopefully somebody else will answer the phone that's ringing at my house here. That never happens. But why would we want to use Soundcard connections instead of a TNC or some type of hardware device? And I really think that Soundcards are certainly as good as any of the hardware interfaces, and maybe in many ways a lot better. Certainly we have very good performance with Soundcard modes. Now, I've been around this for a long time. I started playing with Soundcard interfaces, you know, back when it didn't work very well in the, you know, Windows 98 and Windows XP years. And you know, we had computers with a lot less performance back then, and to do the you know, this FFT type analysis, digital analysis on Soundcards was really taxing the processors that we had at the time pretty hard. Nowadays, you know, we've got computers that are running you know, many gigahertz and cycle speed. We've got tons of memory, hard disk space, all of that. These are amazing computers that we have available to us nowadays. And we even have Soundcard interfaces or Soundcard adapters that are very sophisticated DSP devices, you know, 96-bit performance, really with the right software, we can build very sophisticated modems utilizing a Soundcard interface. And so, and some of these are pretty cheap. You know, it's certainly a lot less expensive than a dedicated TNC type device that really can only do maybe one mode or maybe two modes, something like that. We can do lots of different modes with a Soundcard interface. They certainly do seem to have a superior decode performance over hardware devices, and I'm talking there specifically about packet radio. When we do a comparison of a hardware TNC against a Soundcard with a software TNC application, you know, we are pulling packets out of the noise and decoding them where a hardware TNC would ignore the packet altogether. So And of course, you know, it's not all about MCOM and that sort of thing. There are other things that we do with this hobby, and many of the other digital modes that you might be experimenting with will require a sound card interface. You know, why not go down this road? When I was asked to do this presentation, I said, really, you know, do-it-yourself interfaces, is it really worth the effort? So there's a couple reasons why you might want to do it yourself. Save money, but I caution you on that, because you might, you know, there's certainly been some projects I've gotten into where I thought, hey, I could do this myself, and started going down that path, and well, I needed you know, one of these connectors, and I needed this device that I didn't have, and I needed a case for it, and blah blah blah. And you know, all of a sudden, I ended up spending more money than, you know, if I just bought a product already made to do the function. So be careful with that. You can certainly save money if you have the resources. If you don't have the resources, you might end up spending more money trying to put something together on your own. There is, of course, the satisfaction of a technical challenge or skills development, and that's important, I think, for many reasons. We are the technical folks out there. We probably got into this hobby because we like technical stuff. And even if I'm thinking about ARES and disaster communications, having those technical skills when things have broken, knowing where things go, how things go together, and what needs to be connected, and what signals are needed. I think that's really important skills to have. And then, of course, you could also customize the design for specific needs. If you had, you know, a particular type of radio that had specific needs, or maybe you had a particular application software that you wanted to run, and it required certain things, you could, of course, customize the design for that, or a product may not have what you need. So these are good reasons to do it yourself, as it were. There's a couple of different definitions of what do-it-yourself is. For some people, that means I'm going to buy a kit from a manufacturer. It's going to come with a, you know, in a box with all the parts, circuit board, some instructions, and lay that all out on my workbench, get the soldering iron heated up, and put the thing together. And plug it in, wait for the smoke to clear, and you know, or put it on the air. That's certainly a very viable option. There are, you know, it's not like the old Heathkit days. You know, Heathkit, I guess they technically still exist, but it's not like they used to be. But there are still several folks that are producing kits that you can put together, and that can be a really good way to go. Obviously, you can also, you know, we have the internet now. You can do a search out on the internet, look for a schematic or a design of some kind, and then scrounge up all the pieces and parts you need to make that happen, and put something together. And you can also, if you got the talent, and I'm sure there's probably folks on this call tonight that have the talent to you know, design and build from scratch. You come up with the design and lay it out, get the parts, and put the whole thing together. So I'll have a couple of quotes here from Thomas Edison, who's not one of my favorite folks in history, but he did have a few interesting quotes. So if we all did the things that we were really capable of doing, we would literally astound ourselves. So, you know, why not do it yourself? So I want to talk a little bit about exactly what a sound card interface is and what it is not. There's sometimes some confusion here, and you know, basically it's a simple signal interface. It is not a TNC. A lot of times I'll have people call me up or send me an email and say, hey, I'm having trouble getting my SIGNALINK TNC working, and I usually respond with something nasty like, well, that's because it's not a TNC. It's really just a very simple signal interface. TNC does a lot more than what a sound card interface does. Some of the things, it may provide ground isolation between the radio and the computer, and I'm going to talk about that, whether that's necessary or even desirable anymore. Of course, it has to create the push-to-talk signal. We got to be able to, you know, put your radio into transmit mode, and that can get us, that can cause us some issues sometimes. and we'll talk about that a little bit too. It does not process the signals from the radio or the signals that it's sending to the radio. All it does is, it's essentially a digital to analog converter and an analog to digital converter. We send it bits and it turns that into an analog waveform, or it takes an analog waveform and turns it into bits. It has no idea what those bits are and doesn't care, okay? Doesn't know whether it's modem tones for your packet radio or if it's Linder Ronstadt. It doesn't know, doesn't care, just sends it on out, the output. So all of the signal processing is going to be done by the software that's running on the host computer, okay? And that software is going to do the modulation, demodulation, essentially. It's going to do the timing and the control signals like push to talk. And of course, it'll implement whatever the data protocol is that we happen to be utilizing. So here's an example of a Soundcard interface, the SIGNALINK, SIGNALINK USB. Many of you, I'm sure, either have one or have seen them in operation. Again, simple device. It's powered by the USB connection. Relatively inexpensive, $100 or so. You have to have a way to connect this to your radio. So either you have a data port on your radio, which unfortunately on a lot of the manufacturers are discontinuing that data port on the back. But if that's not an option, then we can connect to the speaker and microphone connections. And the SIGNALINK does have transformers in it that do the ground isolation, and that tends to limit the audio bandwidth, okay? And therefore the maximum data speed that we can push through a device like this. And I'll talk some more about that here in a minute. Here's kind of a block diagram I drew up of a SIGNALINK USB-like device. And let me turn on my pointer here. So coming in on one end, we have a USB connection here, and that's going to provide power to the circuitry here, but also the digital signal coming into or going out of the device. And inside there's going to be an audio controller chip of some kind, and that's going to have the digital analog converter and the analog to digital converter, possibly some other I/O lines in there. To drive LEDs or to respond to switches or something like that. We'll probably have some amplifiers out here, op amps, to amplify the signal going out or coming into the radio, possibly even with some control on there on the levels. And in the case of some of our interfaces, we'll have a isolation of the audio lines here, typically done with transformers. Okay, and then this is going to go on out to the radio's transmit audio and come in from the receive audio. In addition, we're going to have some kind of way to activate push to talk. Now, in the case of the SIGNALINK, we take some of the signal, or we take one channel of the signal off of here, and we run it into a Vox circuit, voice operated transmit. So when it hears sound, essentially, it's going to fire off this relay inside there, which will be connected to the push to talk lead on your radio. Again, what we're seeing, on the USB side, we're seeing, ones and zeros or ons and offs, however you want to say it, digital information here. And then coming out of that audio controller chip, we're going to see, some kind of analog waveform. And same thing coming back from the radio, you're going to have some kind of analog waveform. It's going to go through that audio controller chip, and it's going to turn it into ones and zeros that go back out the USB connector here. And that's really all this Soundcard interface knows. Again, it doesn't know what this data is. It's just seeing a waveform in here, and it turns it into digital data. And it's going to be up to the software that's running in the host computer to do that interpretation. Some of the different modes we have out there that can operate with a Soundcard interface. For Winlink, we've got ARDOP, which is an HF mode. We have VARA, which is an HF mode and a VHF mode, but it's actually two separate programs that do that. And then, of course, we have good old packet radio, either at 1200 or 9600 bits per second. And then VARA FM, which can operate, take advantage of the higher signal to noise ratio that we have on FM transceivers and get much a higher data rate. So you can kind of see what the different data rates are here. These are of course under ideal conditions. Your mileage most certainly will vary depending on propagation and signal to noise ratio, what you know, the RF path that you happen to have. I do have one more listed at the top here, but you'll see it's crossed out because we are deprecating that mode out of Winlink. It's, you know, it's certainly the slowest of the modes out there, and really these other modes do much better. So the development team decided we've got too many ways to do this, and we're going to drop one of these out. It's still in the program today, but you'll probably find that most of the gateways have turned off their WinMore connection. ARDOP is included with WinLink Express. If you want to do these other modes, VARA or Packet, you're going to have to install a separate TNC, software TNC application to do those. Now let's talk a little bit about you know, interfaces that you can get that are, you know, already made. You know, here's you know, we had a few weeks ago, Kevin was on from Masters Communications. Here's one of his boards, the DRA30, which does all of this. The rim light has been talked about in the past as well. This plugs right into the back of a transceiver. They have a couple different models that have the appropriate connector for whatever the transceiver is, so it just plugs right into the back of the transceiver. There are many, many other similar type interfaces to those that are available. And then on the homebrew side, you know, you can throw something together yourself. And we'll talk about this device here, which is, you know, the one that I built before I knew there were better options out there. Don't forget that there are many transceivers nowadays that have a Soundcard interface built into the transceiver. You know, I've had questions come up from folks that, you know, saying I'm having trouble getting my SIGNALINK to work with my IC7100, and I scratched my head for a minute and I said, well, why are you using a SIGNALINK? They said, well, I want to do digital. And I said, it's already got a Soundcard interface in it. All you got to do is plug that USB cable in and you're good to go. And they're like, oh, why did I spend the money on a SIGNALINK? So keep that in mind. There are several rigs out there that have this capability built into the radio. And so, you know, literally all you need is a USB cable going from your computer over to the radio, and you're good to go. Load up the software and you're good to go. Okay, so you want to roll your own. As Thomas Edison would say, to invent, you need a good imagination and a pile of junk. So if you've got that workbench, you know, wherever you do your building out there, you've got a workbench that you've got, you know, resistors and capacitors and transistors and you know, all the connectors and prototyping boards and all of that stuff out there. You're probably in good shape to put together a device like this. On the other hand, if you've got to order all that stuff, you're going to end up spending a lot of money. And I want to talk a second about, you know, if you go to Mauser or somebody like that, and you want to order a couple of resistors and a couple of transistors and a couple of capacitors, you don't get the price break for ordering in large quantities. So you're going to pay, you know, the higher rate for all of those parts. You're going to pay way more, you know, you're going to pay like 50 cents for a resistor, which is kind of silly. And also, don't forget that they're going to hit you with a pretty substantial shipping. Mauser is really bad. You know, you can order 3 resistors from Mauser. They will charge you $15 shipping, and they'll put those three resistors into an envelope and put it in, you know, put a stamp on it and mail it to you. So yeah, they are making money on the shipping. So keep that in mind when you start planning this out. If I have to buy a bunch of parts, you might not be saving money doing this. Now, it still may be worth it to you if you're interested in building and learning how to do that. Okay, it might still be worth it, but you may not be saving money at the end. Okay, so we're going to need 4 signals from my Soundcard interface going to my radio. Basically, we need transmit audio, we need receive audio, we need a push-to-talk connection, and we need a ground reference for all of those connections. And that's all we need, just those 4 lines, and we can do everything we need to. Now I'll take you back in the beginning. This is a picture of my shack from a long time ago. I want to say probably around 2000. People were talking about this new mode, PSK31, and it was real easy to get running, and you could run it off the sound card built into your laptop. All you had to do is, hook it up to the radio. And I thought, well, I'm going to give this a shot. And you can see this is really ugly. I mean, I took the headphone jack here and ran it into the audio in on my computer. I took the speaker output from my computer and, jury rigged some resistors in here to drop the level down a little bit, and then shoved it into the microphone connection here. And, believe it or not, I made many contacts on PSK31 with that messy setup. It did work. Obviously not the best. So, eventually I rolled it into a box here, and I added some additional circuitry in there and cleaned it all up with nice connectors and made it look nice. And actually, believe it or not, this interface, which I built like 20 years ago, is still in operation today. It's not doing digital anymore. It's providing the SIGNALINK connection to my local repeater here, and it's about to be replaced. But it worked, and it still is working. And I'm sure I could still run packet radio through it if I had to. So what's inside the box? Okay, here's those connections that we had to provide. Again, I need something going out to the radio, okay, or something coming from the radio going into my sound card interface, okay, and then coming out of my sound card interface going into the radio's transmit circuitry. And we probably need to do some kind of interfacing between the two. Certainly, coming out of the sound card, the level is going to be a little bit too high to just drive a microphone circuit directly. You're going to have to attenuate that a little bit. And possibly the same thing going the other way here, coming from the radio. If you're connecting to the speaker output of your radio, going into the sound card interface, again, you'll probably have to do maybe some impedance matching or maybe some attenuation there as well. The transformers in use here, and by the way, this circuit came off the internet from, way back when there was a Radio Shack and you could go down and buy parts down there. And these transformers are put in here to isolate the ground between the two, between the radio and the computer. And I'm going to talk about that here in a little bit. But so this is providing me with my transmit audio and my receive audio, okay? And then down here is the push-to-talk circuit. And in this case, what I utilized on that particular interface was I took the communications port, the COM port, or the serial port out of the laptop there. And we just take one of the lines on the serial port, which conveniently is called request to send. And we, very simple interface here. Just take that one line and, we'll drop the level down a little bit with the resistor here, and then protect it for reverse polarity because the RS-232 interface goes both positive and negative. And then just fire a 2N22, PNP transistor here, tie that to your push-to-talk line, and we're good to go. As long as the software has the capability of raising this line on your serial port, we can use that to assert the push-to-talk function. And virtually all of the software applications can do that. Touching on ground isolation again a little bit, when I had this interface, you'll notice this ground is coming from the ground of the computer going right to the ground of the radio. So I kind of blew away the fact that I was doing isolation here by providing this ground here. One way to get around that was to use something like this. This is an optical isolator. So in this case, again, we're going to use the request to send line off of the COM port, put that into the optical isolator. This essentially is a light emitting diode inside of here, and it's positioned right next to a photosensitive transistor. So we light up the LED, and it causes the transistor to conduct, and we fire off the push-to-talk lead. But there's, physical separation here. There's the only thing going between these 2 points is light, and so that isolates my ground there. And I think I switched that circuit at some point in time to using one of these optical isolators. Another way to assert the push-to-talk. Here's another circuit I found on the internet. This is essentially a Vox circuit right here. So we've got sound coming from the computer. Again, we've got isolation going on here with the transformers. We send part of that signal right off out to the mic input circuit, but I'm also tapping off here and taking some of that signal into a rectifier here. So we rectify the sine wave, charge up a capacitor here, and then feed that into the transistor, and that asserts our push-to-talk function again. When the sound goes away, this capacitor will bleed off, and we'll drop the push-to-talk connection. So getting this capacitor right is going to be critical. You don't want it to take too long to start transmitting, and you also don't want the radio to stay in transmit once we've done sending audio. So getting the right size capacitor here will make a big difference. But a circuit like this can certainly be made to work, and then you don't have to have a serial port on your computer to assert the push-to-talk function. There's other ways we'll talk about here in a minute. So the design I just showed you there is making use of the sound card that's built into the computer. That may not be the best option. There's a couple reasons for that. If you have a lower end computer, the built-in sound card may be of lower quality components. And the other issue I have seen with those sometimes is they pick up some of the noise from the other oscillators that are going on inside on the system board inside the computer. And so that could possibly affect your performance a little bit there. The other probably the bigger problem with using the built-in sound card in your computer is that then it's the same sound card that's used for all other audio that's going to be happening in your, within your operating system. And we really don't want, you're keying up your transmitter and saying you've got mail or something like that. So you have to be very careful if you're going to use a built-in sound card that you disable all system sounds from the operating system point of view, and also that you make sure you're not streaming any YouTube videos or anything like that, because you're going to be transmitting that sound out off of whatever frequency your radio is dialed up to. So a lot of our interfaces will make use of a dedicated sound card device, typically USB connected these days, because of course that's the connection of choice on all of our computers now. Typically we don't have serial ports anymore. We don't have any other connections other than the universal serial bus. So as far as putting together something here, if you're not going to design this from ground up, I would probably start with something that's already out there and functioning. And All-Star, if you're not familiar with All-Star, All-Star is a voice over IP application for connecting repeaters and or simplex links together, utilizing the internet. And it's been around for quite a while. It's, sophisticated software, utilizes the Asterisk back-end software, which, is really initially for telephony applications, but it works perfectly for, essentially radio over IP. And there's a lot of different interfaces out there to build your own, All-Star repeater or your own All-Star simplex link. And, why not start with a design like that that's already, in use by a lot of different folks. Now, All-Star is, of course, a voice application, but these seem to work just fine for digital operations. we might limit the audio bandwidth a little bit for voice applications, but the interface can certainly handle much more bandwidth than what we're using for voice, and it works perfectly for digital. In fact, that's how I kind of went down the road. You know, I had that other interface that was, you know, usable, but I wanted something different. And I had started doing some research on All-Star, and I was looking at these interfaces on the internet, and I said, hey, you know, I'll bet these will work for digital. And I built one up for myself, and indeed it did work. And then I found out that, you know, hey, there are all of these different interfaces out there that are doing this. So that's where I'll take you through here in a minute on what I came up with and what you might want to roll yourself. So I wanted to talk about ground isolation a little bit. You know, the transformers in the interface I showed you there, and in some of the other devices like SIGNALINK USB has transformers in there to do ground isolation. You know, before I was a ham radio operator, I was a sound engineer. I did live sound mixing for rock and roll bands and live theater. And certainly I did plenty of searching for ground loops in my various audio connections there. And I understand the reason for, possibly needing ground isolation. But, you know, that was the old days. And nowadays, it just doesn't seem to be that important anymore. Most of our computers these days operate off of a power pack that's, you know, doesn't even have a ground connection on it. Or if it does have a ground connection, it's probably not tied to the negative side of the DC output from that going into your computer. I very rarely see any kind of ground loop kind of condition that's going on these days. The other big problem with utilizing transformers is that they're going to limit the amount of bandwidth you have available, limit the amount of audio bandwidth. One of the things, you know, something else I learned when I was doing sound engineering work, you know, there were times when we had to have a transformer in line. You know, a typical example of that would be a direct interface or a DI board to connect a guitar to a mixer. And typically a guitar pickup has got very high impedance output, and you're going to run that into a microphone input on a mixing board, which is typically very low impedance. So you have to do that matching. To get the bandwidth that you want, you need a good transformer, and I mean a substantial transformer. You know, you've got to, you know, there's permeability in the transformer. You have to have really good permeability in the transformer, and that means it's going to be large, a lot of copper in there, and a lot of nickel and iron to do that. And it's just not going to fit in your interface. I have here, you can see my picture here. I've got one of my hum isolation boxes from my audio days, and inside there you can see those two big, there's not much in here. There's, you know, 4 connectors and a pile of resistors and 2 sizable transformers inside there. And those are nice nickel iron transformers with, you know, pretty substantial windings. And this isn't really even the best box. You're not going to fit those inside your little interface. Those are pretty good sized transformers. They're not going to fit in a SIGNALINK by any means. And, you know, the transformers that were in the older SIGNALINKs just didn't have the audio bandwidth to get really good high-speed performance out of them. And they've now switched them to newer transformers, which are even smaller, and they think those are going to perform better. I don't see how that's possible. And you know, when they talked to me about it, and they did call me up, and I suggested that they take the transformers out altogether, and they said, well, we're experimenting with that, but we're afraid to do that. So we'll see. But I just don't think you can get away with putting, you're not going to get the performance, high-speed performance with little tiny transformers inside your devices. They're just too limiting in the audio bandwidth. And I really don't think that we need this, galvanic isolation anymore. All-star interfaces make use of GPIO pins on the audio codec chip. The GPIO stands for general purpose IO. If you play with a Raspberry Pi or something like that, you know that it's got that whole bunch of input and output pins that can be utilized for, doing just about anything you want them to do. Signaling other devices, firing a cannon, it doesn't matter. So we can make use of these general purpose IO pins for doing the push to talk function on our interface. Typically in the audio codec chip, the IO pins appear as a HID, what we call an HID or human interface device, as far as the operating system is concerned. And so that can be a little bit tricky. We have to have our software that's capable of talking to an HID device and asserting one of the GPIO pins. And we've done that with a couple of the software applications, but not all of them. And I'll talk a little bit more about that a little bit further on. I got this. I don't know, Bob is on tonight, but Bob sent me an email earlier today and said, hey, if you need any additional information for your presentation tonight, I wrote this whole document up on how to use one of these Soundcard fobs to make a Soundcard interface. And that's exactly what I'm going to walk you through here, because that's what I did as well. So Bob's got a good document out here. I'm sure he'd be happy to share it with you if you asked him. So let's look at mine. Again, mine is based on a C-Media audio fob, one of these little tiny guys here. And it uses the C-Media CM119A audio controller chip inside of there. And a lot of the, that's what we see in most of the all-star interfaces. They're using either the CM108 or the CM119 audio controller chip inside there. We have to do some modifications to the board and add some external circuitry. We got to put that push to talk connectivity in there, and probably some attenuation for the audio signals going into and out of the device. Okay, really not very many parts involved in this for what I did, but it will require some pretty good soldering skills, and you'll see why here as I go through the next couple of slides. So here's the device. And that's, you can kind of judge the size by this is the USB connector here. So it's not a whole lot bigger than a couple of USB connectors there. And these are the two 1/8" jacks, one for the headset and one for the microphone. So a very tiny device. And the circuit board inside looks kind of like this. To get this thing open, by the way, you can get these on, Amazon. They were really cheap. I think I paid $5 for them. I think the price has gone up a little bit since the last time I bought one off of Amazon. They were so cheap that they would not even ship it to me, even though I'm an Amazon Prime person. They said, this is just too cheap. We'll lose money on the shipping. We'll have to wait until you have an order of, $25 or more, and then we'll throw these into the shipping along with that. So, I had a couple of them on order waiting till I had to order some other stuff to get my order up to a high enough amount to make it worthwhile for them to throw these in the package with it. You take your X-Acto knife, go around the seam here a few times, and then pry up on it, and you can pop that case apart, and then you can get to the circuitry inside. And then here's the board in there, and then this is the external circuitry that I had in there, which is, like I said, minimal parts count. I'm doing a little bit of attenuation on the transmit audio lead here. That may or may not be necessary depending on what you're doing. And coming in from the receive audio, I've got a 100K pot on there, so I can adjust that level down a little bit. And then coming off of one of the leads on this audio controller chip, one of the GPIO leads, we put a wire on there, and then a 10K resistor into a NPN transistor to do our push to talk functioning. The other parts in here are just if you're going to use this with an HT that uses a load on the microphone lead to force it into transmit mode. It's got those two big connectors on there. And I don't even take those connectors off. The first couple times I messed around with one of these, I tried taking the connectors off, and even with my hot air soldering station, you know, I loosened up the land traces on the board here. So just leave the connectors on. It's not even worth taking them off. So here's, you know, again, our receive audio signal. We've got ground here. We've got our transmit audio signal. So this is the speaker output of the green connector. This is the red connector, or the microphone input connector. And all we have to do then is add this additional line inside of here. Now here's where it gets ugly if you're not good at soldering. A couple of things you have to do, modify on that board. First of all, there's most of our microphones these days are condenser microphones. They need a little bit of bias on the microphone to make that work. So they actually put some DC voltage on there, and that is supplied by this resistor right here. So you could probably leave it on there, but you know, I don't really want the DC offset. So I, you know, flick off this one resistor here. It's R6 on the board, and that gets rid of the microphone bias on here. And then here's the really difficult part. This is as you can see, the CM119 chip. Here's pin 1 over here where the big triangle is. And you count around until you get to this pin, which is pin 13. That's GPIO 3 on that chip. That's what we're going to use for the push to talk lead. So you got to put a wire on here, okay? And that's really tiny. So it takes a little bit of soldering skill to do that, but I've done several of them, so I know it can be done. Okay, so here's what the circuit looks like. I took a piece of perf board. I actually took my Dremel and I kind of, you can't see it on this side, but I ground out the other side so it fit the curve of these connectors right here. So it lays right up flush against the top of the connector, and then just flowed some solder across over onto the board here. And so that's kind of my, not only my ground connection, but also my mounting of the circuit board here. And then on the other side of the board, I've got the transistor here for push to talk. I've got the resistor feeding that transistor. Here's the pot, and the wiring you can see from that pin 13 of the CM119 chip going over here to the resistor for the base of the transistor. I would suggest you put a little bit of hot glue on here, because if you pull on this, you might rip the land pattern off over there, and that would be ugly. And then, of course, you know, just wire up the connector of your choice on here. In this case, I'm using the infamous 6-pin DIN, and you know, notching the case here, bringing that in, connecting it up to the various points on the board there. And that's all there is to it. And you know, believe it or not, this thing actually works pretty good. I don't get the highest performance out of it. And by that, I'm talking about VARA in wide mode. You know, it may not make it all the way up to the level 12 on VARA, but it gets up, you know, it gets up around level 8 or so, which is pretty good. Probably works a little bit better on VARA narrow mode. I know I can always get to the top level on narrow mode. But you know, for basically $5 for the fob here, I think I paid about $2 for these cases, and you know, the rest of it I had in my junk box, so all goes together pretty quickly. And just to prove that it actually does work, I did this one today. Hooked it up to my Kenwood radio here, the TH-F6A, which actually does have a 9600 connection on it, so you can get to the discriminator audio and the modulator audio. And here it is in VARA. I think I had it in narrow mode here, and I'm up at, you know, level 10, transferring a file down. So it does actually work. Speaking of that connector, the data connector on our radios, I do want to clarify a little bit what that data connector is all about. First of all, it's not really, you know, they call it a data connector, but it's really an audio. It's analog signals that are going in and out of here. With the exception, I guess you could call push to talk as a DC circuit, but the signal ones here are analog signals going in and out of there. They say 1200 and 9600. That doesn't mean that you're going 1200 or 9600. That just refers to the types of packet TNCs that we used to connect to these radios. They either came in a 1200 flavor or a 9600 flavor. So that's what they're talking about there. It doesn't really mean that that's the speed that you're going to be going. They really chose the wrong connector here because there's not enough pins. We use one pin for transmit here, and it's both either the 1200 speed or the 9600 speed. Okay, we have two different connections here for the receive audio, one for 9600 and a different one for 1200. Okay? One pin for push to talk, and then there's one pin for a squelch indication from the radio. Would have been nice if we had two data leads here, one for 1200 and one for 9600, but we chose a 6-pin connector and we ran out of pins. So we made the transmit data pin common between the two different modes, and then you have to go to a menu inside the radio and tell it I want to switch to 9600 mode, and that is what changes this pin from either 1200 or 9600. The other bad thing about this connector is that we don't know what the parameters are that the manufacturer of the radio wants for that connector. Sometimes you will see it documented well in the owner's manual. Often you will see that it does not tell us what signal level they want there or what the impedance is. It may not say anything at all about it. So you may have to do some experimenting to figure out what the correct level is to get the performance you want. This is really important. Kevin and I had a discussion today that a lot of folks really don't understand that pre-emphasis and de-emphasis that happens in a radio. When you're connected to the 1200 pin connections on that connector, or if you're using the microphone audio on your radio, you are going through the regular voice path through the radio, which includes pre-emphasis and de-emphasis, and possibly CT/CSS filtering or tone filtering. Okay, so that's going to limit your audio bandwidth, and that means you're not going to be able to push as much data through that path. Okay, we're doing this processing. Pre-emphasis and de-emphasis is kind of like Dolby on the old cassette days. We increase the high frequency on the transmit side. The high frequency audio gets boosted by 3 dB per octave, and then on the receive side we go through de-emphasis. So we reduce the high frequency by 3 dB per octave, which means that we're going to bring that level, or the level back to where it should be, but we're going to be dropping the noise or the hiss down below that. So it works very similar to Dolby transmission, Dolby encoding and decoding on tape. But this processing kind of messes up our digital data. So really it's better if we can utilize the 9600 connections, which go directly to the transmit modulator and come directly from the receive discriminator, okay? And usually, I won't say always on every radio, but usually that bypasses all filtering in the radio. And so we're going to get the maximum bandwidth possible, maybe up to 6 kilohertz on some radios. And so that's where you're going to get the maximum throughput, is if you can utilize the 9600 connections. And I will say, even if you're doing 1200 baud packet, use the 9600 connections. They will work just fine. Again, pin assignments are the same on that 6-pin connector. So, the push to talk lead is always the same pin. but we don't necessarily know what the signal levels need to be. Okay. And just briefly talking about how these external modem applications talk to Winlink Express. We utilize the TCP IP stack or the TCP stack within the computer, but we use the local host IP address. Okay, so that's that special address 127.0.0.1. That says don't go out on the wires, don't go out on the Wi-Fi. The station I'm trying to talk to is within this computer. Okay, and so we just have to match up the ports, and TCP ports are how we talk to a particular application. And so, if I start up Sound Modem as my software TNC, I'm going to have to tell it what port it's going to utilize. By default, it's going to use, port 8100 here. So then I have to make sure that Winlink Express is looking on localhost, this IP address, and the same port that I have set over here. And this communication just stays within your operating system. It never goes out on, the Ethernet or the Wi-Fi. So that's how our programs talk to each other. And remember that these modems or these TNC, software TNCs are separate applications. They are not part of Winlink Express. They are actually a separate application. And so we have to have a way for those two to communicate with each other. Do that with TCP. So this is a conglomeration of all of the different settings, and I'm looking at VARA FM in this case. How do we set up the push to talk? If we're utilizing one of these CM119 type devices, C media devices, where we're using pin 3 of the GPIO on the CM119 chip, you want to select RA board. Okay, so he did take the nomenclature of the master's communications board. Those are the radio adapters, and that's what he put on here. Because we sent Jose a DRA board or an RA board and said, make this work. And so he said, okay. And that's why he documented it this way. But any device, any all-star type device that utilizes that pin 3 of the GPIO for transmit, you're going to set this to use an RA board. Okay. And then of course you're going to select the for the input and output, you're going to select the audio device, however it shows up on your operating system. In this case, I was using an RA35. I had renamed that. It doesn't show up as an RA35. It just shows up as a USB plug and play audio device. But you can rename that within the operating system. Okay. Okay, again, he uses the RA board. There are the other options you have here, CAT control. So if I've got, I'm using a transceiver that's got the Soundcard built into it, like an IC7100, I will select CAT here, and we will actually send the computer-aided tuning or the CIB command over the serial interface to tell the transceiver to go into transmit mode. This is the COM port. So if I was using that old interface, I'd select this one and say, okay, I'm going to use, COM3 and the request to send lead on COM3, and that's how I'm going to do my push to talk functioning. So if you select this one, it'll bring up additional dialogue here, which says which COM port are you using and which lead are you going to use. And then finally, if you're using something like a SIGNALINK that has a Vox card in it or a Vox function in it, then you select that, which basically tells VARA in this case that I'm not going to assert the PTT. You're going to do that on your own, utilizing the interface. Same thing over here. This is sound modem, UZ7HO sound modem for operating packet. And again, you're going to go into the settings in here, pick the Soundcard interface that you're going to be utilizing. And then again, if it's one of these C media type devices, you're going to select for push to talk here, you're going to select external. And then that pops up this little PTT window here where you can select the USB device there. and then it will know that you're talking to that type of device. You can also select a COM port here as well, if you're utilizing that, and then you will have the dialog to set, which COM port you're using, and again, which lead of the COM port that you're going to use. And also you can now set this to CAT as well, and it will give you the dialog to set, which port you're using on, which COM port you're using talking to your rig to send the CAT commands as well. Okay, and then this is, I bring this up just because if you had software that doesn't recognize the CMedia device, there is still a way to get this to work. This program that John Wiseman wrote, CAT 7200, it's no longer named very well because it works for lots of different things. It was originally developed to work the IC 7200, which did not recognize a COM port for doing push to talk, but it does have CAT control, or CIV, or CVI, excuse me. No, CIV. Yeah, I did say it right the first time. So what CAT 7200 does, you have to have another application set up here to build a couple of virtual COM ports. So in this case, we're using COM, which is a free utility that you can get off of SourceForge. And you build a pair of virtual COM ports, and these COM ports are tied together within software. And so what CAT 7200 does is you pick an application port here, one of the pair here, and over on this side, you point it to a CM108. And so what it does is it watches this COM port for an application to raise the request to send pin. And when it does that, he goes over and sends the HID commands to tell the GPIO pin on the CMedia device to go active. And likewise, when request to send goes away, he turns it off over here. So it's a shim that also has to be running. Ideally, all of our applications would have native support, but this is still a backdoor way. If you have an application that can't talk to the device directly, but it can talk to a COM port, we can still get it to work this way. This works with, I've set this up with FLDigi, Direwolf. I've set it up using Direwolf as well. Direwolf, both of those authors we have talked to about adding native control for CMedia type devices. And they both, they're interested in doing that. They haven't, as far as I know, they haven't gotten it into testing yet, but it may be coming down the road at some point, and then we don't have to use this anymore. Talking about transmit and receive levels, this is where it can get a little bit messy when you're utilizing a Soundcard interface, because there's lots of places where you can make this adjustment, and they all have effect on what your levels are. First and foremost is the audio mixer here within Windows. So you bring up the sound interface. If you go to the playback tab here, you can adjust the levels on the playback tab. That is your transmit level. And if you switch over to the recording tab, that is your receive level. So in this case, I've got the recording tab open. I've selected the device that I'm working with, and here's my receive level adjustment. Okay. If you're using a device like a SIGNALINK USB, here's your transmit level and your receive level. Okay, so in addition to these two controls, you also have these two hardware controls. And if you're using something like, the Masters Communications DRA30 here, here's your receive control, and here's your transmit control here, or this one, depending on which way you've got the connector wired. And then finally, if you're using something like VARA FM here, there's a drive slider in here, which also adjusts the transmit level. So there are multiple places where you can adjust the transmit level. and also multiple places where you can adjust the receive level. So you have to keep all of these things in mind. Once you've got them set, they should stick. The one thing that we've seen or we've had trouble with are Windows updates where they kind of renumber the whole USB interface, and so the device numbers might change. And when that happens, if if you bring up VARA and it can't find the sound card that it was talking to the last time, it picks whatever the default sound card is, which is probably not the one you want to use. So you have to go in there and adjust the settings. But I have not seen where the levels get changed. If you've got the levels set, they usually stay where they're supposed to be. Okay, so I get down to here's kind of my last hit here. Building your device from scratch may enhance your technical skills, right? It might save you money. It will certainly impart a certain sense of satisfaction, provided that it doesn't go up in smoke when you put power to it the first time. But is it worth the effort? Maybe buying a kit that has all of the parts ready to go. And some of you know that I do work for Kevin, and I build his DRA boards. This is not a plug for Masters Communications by any means, but it's it's an option. You've got a kit there with all of the pieces and parts. Don't have to scrounge anything. Good high quality board. You have to have the skills to do the soldering, of course. Maybe this is a better option than trying to dig it all up and put it all together from the junk box out in the garage. The other thing I will say, I've seen some really quality work from some folks, really nice home built, homebrew, roll it yourself kind of stuff. I have also seen some really ugly, nasty, bad soldering, wires hanging out all over the place, things twisted together and stuff like that. You got to ask yourself, we're all in, if you're on these calls, you're probably involved with ARES and disaster communications. You got to ask yourself, if it was my spouse or my kid's life that was depending on these emergency communications, would I want you utilizing something that, looks like it came out of the bottom of your junk box, or would I want you using a really nice looking piece of equipment? So if you're going to build this up and you're going to use it for disaster communications, take the time to build it right. Build a good, solid piece of equipment that's going to be reliable for those disaster communications. Okay. Last word from Thomas here. The 3 great essentials to achieve anything worthwhile. First, hard work. Second, stick-to-itiveness. And third, common sense. Okay, so think about it. Is this really worth the effort, or should I just buy the device? Okay. This, just talking about Winlink, continues to be used for MCOM stuff. The Winlink development team doing a great job of adding new features and function. Okay. And with our Soundcard interfaces, we have a relatively low cost but high performance solution for transferring data over RF. I'll give you the bonus here. If you do have that SIGNALINK and it's one of the old ones, this is what mine looked like before I did modifications to it. You can see down here at the low end of the audio spectrum, it was pretty darn ugly. After doing some work on it, I put new transformers in mine. By the way, I've ultimately taken them out altogether, but I did put new transformers in there, changed the op-amp bias control and put some filtering on the USB power bus, and made the power switch actually turn the power off to the device, which it does not do from the factory. And after those mods, you can see it actually cleaned up the low end frequency response quite a bit. If you go to this page, there's a lot of articles out there on the internet on what modifications need to be done to improve the performance on SIGNALINK. As far as I know, they had the current production, they have done all of these things. They've cleaned it up. They have the new transformers in there, which they say have greater bandwidth. I'll believe it when I see it. But they have certainly done these other things as well to clean up the signal interface. Okay, I hope there's some good questions out there. We still got plenty of time here to answer questions, and I'll do my best to answer any questions. And I think there's a couple other technical folks out there that can probably help out if you stump me, which probably wouldn't be too hard to do.
Okay, please raise your hand if you got a question. There's Lee, are you there? There's been questions pop up in the text in the chat thing. Did you catch any of those?
Sure, I can relate some of those back. Let me start with a quick comment before we begin the questions. Call sign SM7YTN. I wish I had watched this before I built my sound modem. I wanted to start with that. All right. Let's see here. Let's see, I think we've upgraded, we've addressed the upgrade possibilities for the older SIGNALINK. Does Tom W3TDH want to address that question still?
No, I don't.
Okay, that was answered then, addressing the upgrade possibilities of the older SIGNALINK. And I don't see any hands up. Maybe we'll go to the next one. Is the isolation more for the computer's sake than the radio? If you're using an older radio, say a Kenwood TS440S, would you want the isolation?
You know, I would say no. I don't think you need it. And yeah, I suppose there could be a safety issue there. But it's primarily for noise on the audio lines that they were doing ground isolation. And I would certainly try it without the ground isolation and see if it works acceptably. If folks are giving you bad signal reports, or if you're having difficulty connecting and stuff like that, then you might have to do that. Probably you could get by just by doing some good ground bonding between all of the devices that you have connected, which you should be doing anyway. And that will probably get rid of any ground loops that you have. And so again, you know, I'm not big on transformers except where they're needed. And if they are needed, then you better be spending money and getting some really good transformers. Otherwise, you're just going to limit your bandwidth.
Okay, thank you. Next question. Does the existence of a conductive pathway between the transceiver and the computer raise any additional risk of lightning damage or other static discharge?
Well, if you haven't done your ground system, you know, per all of the rules, then a nearby lightning strike, or heaven forbid, a direct lightning strike, will find various paths through everything. And if, you know, if it's coming down your antenna line, and there's and you don't have the antenna system bonded to the electrical system with a good, high quality, low resistance bond, then there could be 1,000 volts differential between, you know, your antenna system ground and your house ground. And yeah, that will carry through probably to every piece of electronics in your house. I like to tell the story of my former emergency manager who took a lightning strike nearby her house to the tree right next to the house. It jumped over to the house wiring and took out every single piece of electronics in the house, TV, all the Wi-Fi, computer network, everything. And the reason that happened was because when the cable installer installed the cable system, they did not properly bond the ground of that cable system coming in to the house electrical system as they should have done. And you know, voltage went everywhere in the house and took out literally everything. Now, they were able to prove that it was the cable company's fault, and cable company replaced all of their equipment. But you may not have that option if you didn't put your antenna system in correctly. So good, you know, I don't worry too much about it here where I live because we don't get very many electrical storms. But if I live down in Florida where you get a thunderstorm every afternoon, I would be bonding everything together by all of the rules and making sure all of my ground system would good, and I had lightning arresters and everything.
Okay, thank you. Next question. It's a little bit vague. We may have to ask Tom to come on. What spec do we need to look for as the specs on the sound fob itself?
Well, if you're going to utilize, I would say you'd want to have a sound fob that is based on the C media chip. And there's basically there's probably a couple of different chips that they might be using. The older ones used a CM108 chip. The newer ones are using the CM119 chip. You really want the CM119A. Kevin will tell you don't get one that has a CM119B in it, but you may not have that level of understanding without taking the thing apart. I doubt if you're going to find any real specifications on them. If it's a computer sound card, they're all pretty close to the same specification. So I don't, there's no particular thing I'd be looking for specifically on that. I think they'll all work pretty well. The main thing is, I would be looking for one that utilizes the C media chip because that's what our software knows about, knows how to talk to. There may be other chips that work the same way, but I'm not aware of them, so I can't recommend one way or another.
Thank you. I'm going to go ahead and call Tom. He does have his hand up, and he did ask that question. Go ahead and unmute, Tom.
Thank you. My question goes back to the ground danger problem. I spent my working life as a site installer. Did a lot of grounding, and I've done it here. I even had to dig the trench clean around the house to make sure everything can be bonded together and use the number 2-aught, because that's what they gave me instead of number 2 at the supply house, same price. So I said, sure, I'll take it as the ring from one side of the house to the other. And I've got more rods in there than you want to count. Of course, I still own a demolition hammer to put them in, which makes it easier. But it is grounded, it is bonded, just the way a commercial site would be. My only question was, having that metal pathway between the two parts of the system, is that going to create some additional risk of damage? And, I know how to install it, but I don't know the technical stuff behind it. I'm an electrician by craft.
I can't see how that would create, I mean, it sounds to me like you've got bonding down, to a science there. So I don't see how that could be causing any additional concerns. And I wouldn't expect to see, if you got the rig is attached to all of that and the computer system is attached to it as well, I don't see how there would be any danger, safety danger or system damage that could occur from that. You take a direct hit to the house, I still say all bets are off because one of my repeater sites took a direct hit to the power box on the side of the building and it vaporized the power box. I mean, there was nothing left of it. So that's a lot of current. That's all there is to it. But no, I think it sounds to me like you've got it all done right, and I can't think of any reason why there would be any additional risk there.
All right, thank you. Comment before we go back to questions from AK6RM. Really clear, comprehensive, and accessible presentation, especially helpful when addressing the whys behind assertions. Thank you very much. All right, back to the questions here. Let's see, I think there's really only a couple more. Please confirm that you can use the 9600 BPS pen for 1200 packet on the data radio.
I do it all the time. It's, technically, I guess I'll say in the ideal case, if you know that the station you're connecting to is utilizing the 1200 pins and they're doing pre-emphasis, de-emphasis, and you're connecting to the 9600 pins and therefore not doing pre-emphasis, de-emphasis, technically there would be some what we call blanking on the word now, but twist. There would be some twist in the signal there. But what I have found utilizing UZ7HO sound modem, he's got multiple detectors running at the same time. So when the audio stream comes in there, he's looking to see, or he's doing one detector with pre-emphasis, one detector without pre-emphasis. You can have multiple detectors. You can add additional ones for being a little bit off frequency. And if he gets good data off of one of those detectors, that's what gets passed on to the application. So I have not seen an issue with utilizing the 9600 pins, even for 1200 baud packet. Now, I won't swear that if you're doing that and you're connecting to an older TMC at the other end, and it's connected to the speaker and microphone jacks, it may have trouble decoding you, but I really haven't seen that at all recently. And I think, again, I think the software modems are very good at pulling packets out, even if they have a fair amount of twist in them. You can do some adjustments on the on UZ7HO sound modem. If you take the defaults, he's running all the decoders. But if you want to tune that, you can say, okay, I want to do pre-emphasis, or I want to do de-emphasis, or not. You have the choice in the software to make those settings changes. But I have found just using the defaults and using the 9600 pins, I never have any trouble making connections.
Thank you. All right, one more question. What about using a Vishay IL 300 for galvanic isolation? It appears that it can do 200 kilohertz signal rates with little thermal nonlinearity.
Okay, I'm not familiar with the product, so I'm not sure I can answer that question.
Okay.
I don't know if anybody else on is familiar with that product.
Well, we'll give it a minute. If there's a comment, you can put your hand up and we'll call on you. And to put your hand up, it's at the bottom of the participant screen. Let me see. I believe there's one last. What are the audio chips you referred to?
So I'm talking about in the device here. I don't know if you can really see this or not. This is a which one is this? DRA 36. So you can see the one surface mount device in there, right in the middle. That's the C media chip there. Very tiny chip. By the way, if you build one of these, you don't have to put that chip on. Kevin does that for you. And that's, you can, if you go up on Google or whatever and do a search on, C media or CM119A, you can read the data sheet on that. But again, I wouldn't suggest, if you really want to build all the way from scratch, yeah, you can buy just that chip and then put it on your board and build it all up from there. I wouldn't go that route. I would just buy a USB sound interface and then add the additional circuitry to do the push to talk and signal shifting, and go from there. If you want to go through all that work, sure, you can get the CM119As. Kevin, you want to talk about why you wouldn't want a CM119B?
Hi there. My name's Kevin, W3KKC from Masters Communications. just to really briefly touch on the reason why you wouldn't want to use a CM119B audio chip for one of these sound devices is that particular integrated circuit has some feature sets built into it which are very good if you're going to use it for its intended purpose. Understand that the intended purpose for the C-Media chips is for a headset and a microphone, USB headset and microphone. So there are some filters that are built into the CM119B that are not able to be easily turned off, and therefore that limits the audio. And for our digital applications, that's certainly something that we don't want to do, is purposely limit the audio, which limits the bandwidth, which limits our throughput. So without getting really, really technical, there are several reasons, but the bandwidth limiting functionality is probably the prime reason, the number one reason. The other thing I want to mention is at Masters Communications, we have a lot of different sound cards available. You know, a lot of people might say, you know, boy, I can spend $7 on this interface and $2 on this case and a couple bucks on a cable. You know, certainly end up putting maybe $20 in it. Realize that we do have a very inexpensive kit that's available called the RL20. The RL20 is a complete radio adapter that's $20 in kit form. I don't know that you can source all of the components that are necessary yourself for $20.
You can't.
Yeah, and I'm not saying that because I want to plug. This isn't a sales advertisement. Please understand we're here because we want to try to help people understand these applications and save money over some of the things that are out there. So an RL20 is a $20 kit. It comes complete with everything, including a CM119A that's pre-soldered on the board. All of Masters Communications kits that have surface mount technology, the surface mount comes pre-assembled, pre-installed on the board.
Thanks, Kim. So yeah, you know, if you're going to build this up, you know, all the way from the chip on up, then yeah, I would look for a CM119A. But you know, again, that's really going the hard way. I would start with something that's already a sound card interface, or you know, a sound card fob, and then add the additional circuitry to that. And Kevin's absolutely right. You know, again, if you're buying onesie and twosies of these parts, you don't get the price break for, you know, buying 100 of them, and you throw the shipping on top of that, unless you happen to have a distributor right down the street from you. You're going to spend way more than 20 bucks by the time you source all those parts and put it all together.
All right, thank you. We'll do one comment and then we have a hand up. So W6EDT, go ahead and unmute, and I'm going to read the comment. Let's see here. Patrick W0PCD says, thank you for the great presentation. I learned a lot, 73. And KE5ZDZ, a very comprehensive talk on a challenging topic. Thanks for your fine presentation. So we've got a lot of good comments. And now let's go. Dale, go ahead, take it away, W6EDT.
Thank you very much. I hope you can hear me. Good. So I asked the question about the IL300. Although I understand galvanic isolation should probably not be a big issue, I'm just kind of old-fashioned, and I prefer to have isolation among devices that are interconnected if I can do it, especially a fixed PC, you know, not a laptop or something like that, and a radio. But so the IL300, but just in general, I guess my question is, other than bandwidth considerations, is there any reason why opto-isolators aren't a good choice for galvanic isolation as opposed to transformers in your design experience? That's really my question, W6EDT.
So the last part of that, you said optical isolators?
Yeah, opto-isolators, you know, the diode
Yeah, okay.
transistor thing.
But, you know, I got no problem with that. That's, you know, so you're talking about isolating the push and talk lead. You know, that's fine. It's the issue is more what you're doing to the audio by running audio through the transformers.
Agreed. And so the audio isolators that I was talking about specifically, I'm not a Vishay salesperson or anything like that, but the IL300 claims 300 kilohertz, no distortion, and pretty good temperature linearity, which is the other big problem with opto isolators, of course, because they have a feedback circuit inside. Anyway, if there's no bandwidth limitation really in the opto isolator, then it might work.
Sure. Yeah.
But it's fun to play with anyway.
Yeah. Yeah. And also it depends on what modes you're going to be operating. If you're going to be operating 1200 baud packet, you can have transformers in there. It's not going to affect it. If you're going to operate VARA FM in narrow mode, you probably get pretty decent performance out of it. But if you want to get the highest performance out of VARA in wide mode or even packet 9600 packet, then bandwidth becomes a real big issue.
Is it roll off at the bottom end is what you're concerned about?
Yeah, for VARA it's roll off at the bottom end. It's probably at both ends for 9600 packet, although I'm not sure.
Okay, thank you very much. Great presentation, really informative.
Yep, thanks.
Okay, that's all the questions I see in the chat.
Hey, we're coming up to 1928. It's about the right time.
Yeah. Will you send the presentation to me so I can include it with the video afterwards?
Absolutely.
Appreciate that very much. Any more questions? That was a great presentation.
Brief question, please.
Okay. Go ahead, Bob.
Kevin. Yeah, just a quick one for Kevin. I thought I saw reference to a DRA 70. Is that out? And what's the spec?
So the DRA 65 and DRA 70 are both out. They are basically a DRA 45 and DRA 50 with the additional Vox capability. So we've had some people say that, I don't want to go through all of the software hassles that I have to try to make the radio adapter key with FL Digi or Vera HF or whatever. And I just want this to be simple, with a Vox. So we went ahead and redesigned the DRA 45 and DRA 50 to add the functionality of the of Vox, and they are now available from the website.
Way cool. Thank you very much.
You're welcome. Thank you.
Well, thank you. Thank you, everyone. Before we shut it down, I want to make sure there's not some more questions out there. I don't see any hands raised. I don't see anything more in the comments, but occasionally somebody was on a phone or whatever and couldn't do either one. So we'll give it a shout out there. Well, hearing none, Scott, I want to really thank you for your presentation. Kevin, it was good to see you again. Many of you remember he gave a presentation a while back on the products they have, and he's got a good line. You saw some of them tonight. And unless there's something else, I'm going to wrap it up for the night. Get ready for the next presentation. Again, thank everyone. And we'll see the best of 73s to everyone.
Thanks, everyone.
Thank you, Scott. Thank you, Dan.
Awesome presentation.
Scott, I think you broke yesterday's record, incidentally. For attendance.
What did we hit?
I think it was close to 150. What was it, Barry?
I saw 150.
Yeah. I think it went over that, but it was right in that vicinity, at least 150 and maybe 152, 53, something like that. Good turnout.
I only saw 25 at a time, so it wasn't too bad.
Yeah, it works well. Alrighty, with that final comment, and I'll just get the heck out of here. See 73s and see you next go around, everybody.
Thanks,
Okay.
Dan.
Thanks a lot.